Oh. Thank you.
Thank you, ma'am. I request Professor Kumar to now begin with today's session on teaching data structure. Thank you.
And, assuming that you have taught or teaching data structures. So how many of you have taught or teaching data structures now? Or taught, whichever, or. Okay. I think the group is heterogeneous, so I hope all of you have studied data structures. Okay, any of you have not studied data structures? Okay. Shall I also assume that you are comfortable with pointers? Yeah? Okay. Let's make the session interactive. I have planned certain activity. I don't know how much I can cover. It depends upon you as well. Let's make it interactive. Whenever you have any query, please ask. Okay? So, you will have to install MinGW in case you're working on Windows. In case you're on Ubuntu or some Unix flavor, it doesn't matter. Okay, the link is, I think, shared by Dr. Vandana in a WhatsApp group. Okay, you don't require your laptop in the morning session. You can sit back, relax, and think with me. Okay. I speak a bit fast, so in case you miss something out, you can ask me to repeat. And all of us are from the same field, so there should be no issue with language per se, right? This happened way back in 1991. I was getting my child, and my wife was in labor, and the doctor decided to go for a cesarean section. I wanted to ask the anesthetist what sort of anesthesia is going to prescribe. I asked him whether he would administer local anesthetic or global anesthetic. He didn't realize, he was blinking, local anesthetic or global anesthetic. Then I realized the word they use in medicine is not global, but general. Right? I didn't realize it because I'm used to this language. I was doing training in Pune for a company called Geometric, and that's on the outskirts of the city, Hinjawadi. And for whatever reason, they had booked a hotel room for me in the center of the city, a place called Kotrud. And I was doing a training in Python for them. And for the reference, when they sent my name to the hotel, they put the name of the language in front of it. When I checked into the hotel, that person was smiling a lot. I did not understand why he was smiling. At the end, he said, "Mr. Python, please come." Okay. So lots of funny things happen because we have a funny language, but all of us are of the same type, so that shouldn't be a problem. Okay. So we are discussing about data structures and the way I feel it should be taught, right? So what do you think is a data structure? Structure which can help to save our data, organize them. Basically organize some data, okay? Is there a unique way of organizing? Let's say in your kitchen table, you want to put tumblers. How do you put tumblers? Would you put one within the other? One by the side of the other? Which one would you prefer?
One on top.
One on top. Why?
Space, use space.
Assume there is a lot of space. Then?
Okay, as per the requirements.
Yes. So we choose some arrangement of data based on what operation we want to perform. Right? So let's try to describe a bit of it before we write some programs. Whatever I'm working here is yours. So you don't have to copy anything that I key in. Let's digress a bit. Let's say your requirement is to find the square root of a number. How do you find the square root of a number? Be it C, be any other language. How do you find the square root? That's the right thing, right? Why reinvent the wheel? Use the square root function. How many arguments do you pass to the square root function? One. What type normally? Normally a double actually in C. And what do you get back as a result? A double value again, right? That's okay. Float, as a matter of fact, in Python, float is same as double of C, right? In Python 2, we had float and double as separate two types. Python 3 onwards, we have only one. Okay, as I was introduced, I've been teaching for 12 years in college called PES in Bangalore as a visiting faculty. I do not want to do anything non-academic, so I didn't want to join. And I had taught for 25 years in the industry. And I can sort of speak around 20 languages comfortably, 20 programming languages comfortably. When it comes to natural language, I don't even know whether I can speak my language, Kannada, fluently. Okay. So the function square root takes one argument of type double. It returns a double. To use that function, should you know how the function square root works? Do you have to know it? Do you know what algorithm is used to find the square root? Could be Newton-Raphson method, could be secant method, could be something like that. We don't know, right? So normally the implementation of square root function uses the Newton-Raphson method. You have a single guess value, and normally the guess value is taken as 1, and iteratively move towards the root, right? Isn't it a good idea that if you know what is likely to be the square root, pass that as argument? Assume that I'm trying to find the square root of 25. I know that it is likely to be close to 4. So while calling the square root function, I pass 25 and 4 together. And that could help in convergence, isn't it? Do you think it's a good idea? That the square root function be rewritten so that it takes two arguments. One argument is the one whose root is required, and other one is a guess value. Is that a good idea or a bad idea? Yeah?
The guess happens manually.
Come again?
But the guess value happens manually.
Yeah, you have to pass it because you're likely to be more intelligent than the stupid square root function that we have now, which always start with the guess 1. Good idea? So we should tell the C library developers, please change the square root function, make it pass true arguments. Is that good or bad?
So that guesswork will work for smaller numbers, but what about
It always, assume that you give a fairly good root, it's okay. Anyway, it's a guess, right? Guess could be anything. And Newton-Raphson method is a fairly good algorithm for convergence. So do all of you agree that we should change the square root function now, make it 2 arguments? No? Why not?
The very fact that you're using the square root function is because you don't know, right?
You may have a guess. You may know something at least. You don't do anything, okay, pass 1 itself, no issues.
Yeah, I thought so.
Yeah, then so it's still okay to have a function.
It's a machine, no? So let it do the effort.
Fine. But you can also make it intelligent or pass 1. That means now we'll have the square root function which takes 2 arguments. Is that okay?
The number that you're passing, which you're guessing manually, you should know the number. So for dynamic, like for the
I understand what you're saying. If the input is a number, we have no idea while writing the program. So making a guess is difficult. Maybe I'll take number by 2 or number by 4.
you're actually again,
The issue is not at all that. The answer for this, hello sir, answer for this is a big no. A big no. Why? All your earlier programs will not compile anymore. The minute you change the function here, you have changed interface. That is the biggest, most important word in computer science. When you change the interface, all the earlier programs you have written will not even compile, right? You may have another function maybe called square root 2, that's perfectly all right, but you can't do that in a language like C or Python where you can't support overloading. If overloading is supported, it's still not a problem, like C++ or Java, that's not an issue. So the most important word in computer science is the concept of interface. Let me give another couple of examples before we go and write something. Do you drive two-wheelers?
Yes.
So how do you apply the brake? Where is the brake lever? Hand? And I don't know whether any of you were there in our time. Venkatesh must have been there. Yeah, yeah. In those days, the brake was with the foot.
Yes.
Right? When kinetic Honda came sometime in 80s, the brake lever got changed over to the hands. My friend says somebody was driving a kinetic Honda for the first time. A truck came in front of him. He wanted to apply brake. He was looking for the brake lever with the foot. He couldn't find. He crashed into the truck and died. Right? I'm sure most of you would have driven the car. And you know the ABC, right?
Yes.
What happens if they interchange them?
Disaster.
So that is the most important thing. Okay, I will also suggest a few videos which you may want to see sometime, right? So one of the most interesting video that I have come across is by Scott Mayers, the most important design guideline. This is shared with you. You don't have to copy anything that I key in. If I use the
C++ books.
yeah, all those. Effective C++, more effective C++, effective STL, and modern effective C++, then he retired. I don't know why he retired so early. He shouldn't have retired. He has 4 great books. Whatever I key in will be mailed to you or shared in a folder. You don't have to copy. Want to copy, no issues at all, right? Let's think together. That's what I'm more interested in. The most important thing is the concept of interface. Okay. Let's think of a simple data structure. That's what I think we'll discuss the whole day. Okay. What is a stack? Answering precisely is difficult, right? I'm sure that you will trouble your students by asking such questions. What is a stack? If somebody were to ask, yeah?
Last week first out methodology.
What does it do?
Whatever is good last week will be good.
Okay. What operation does it support? Push and pop. How do you make a stack?
Using array.
How do you arrange it? Doubly linked list? What is that? Double-ended queue. Why do you require a double-ended queue for a stack? Array is okay. You can also make a linked list. Okay.
Those are stack is basically you apply the rules of a stack to different storage. For instance, an array or there is no hard and fast rule just to use.
I like that word. Okay. Assume that your requirement is to use a stack. Okay, you go to a store, ask for a stack, you get a stack and start using it. Should you know how the stack is made? Is that made of an array or is that made using dynamic allocation? Should you know? When you drive a car, you steer, when you turn to the left, we expect the vehicle to turn to the left, and so also when you turn to the right, you should turn to the right. Do you have to know how the steering mechanism works? Is that power driven? Is that just mechanical linkages? Is that hydraulic? Do you have to know? And if that particular transmission mechanism is a box, Can you remove that and put another box there which works similarly? Should be possible, right? So I'm using a stack today from company A. Tomorrow I want to use a stack from company B, and both of them might be implementing the stack differently. Should that matter for you? No, right? That is the most important thing we would like to talk about here. So I can make a stack in a couple of different ways. I can make a stack using an array. I can make a stack using a linked list. For the user of the stack, it shouldn't really matter. I want to just check with you. Many of you have taught data structures, and hopefully in C. Did you write the whole implementation in a single file, or did you use multiple files? How many of you use multiple files? Okay. One thing we'd like to clearly distinguish is somebody provides a service and somebody will use it, right? And they do not depend on each other directly. They depend upon the interface of the data structure, right? In case you have studied design patterns, we call it inversion of dependency. If A depends on B, B depends on C, C depends on D, if I change D, all others will have to be changed. If A depends on X and B depends on X, A and B do not depend on each other. As long as X is not changed, A and B can be changed independently, right? In software development, where you have multiple files, lakhs of lines of code, there is no way you write the whole code in a single file, right? In development, the challenge is not development per se, it is maintenance, right? So what I will try to do here in this day's lecture is to distinguish the interface from the implementation, write the client even before the implementation is ready, make them work together, change the implementation and show that the client need not be changed, right? So the most important thing we should talk about in data structure is that a data structure is an interface and not an implementation per se. So basically we say it is an abstract data type. Okay. So when you think of a data structure, we should know what it can do, how it's different, right? We always distinguish between what and how, right? So what is the interface and how is the implementation? It's true of any type per se. Okay. So when we use a programming language and talk about a type like integer, what do we understand by it? What is integer in programming language?
Data type basic.
Okay, what does it mean? What can you do with it?
There is a range for that.
There is a range. I like that because in mathematics, set of integer is infinite. When it comes to implementation, there has to be some sort of a limit, right? And what can you do with it? Add, right? We can add two integer, get an integer. Divide, what do we get? Depends upon the language. In some languages, we have integer division separately, right? Python made a mess of it. Double slashed for an integer division, crazy. Okay. So if I add 25 and 34, what do I get? Add 25 and 34. Some number? 59. How is the addition done? Assume that you are asked to do addition. How will you add the two numbers? 25 and 34 is 59, but how do you add the two numbers? Difficult to describe how you add? maybe the unit digits, add the unit digits, and if there is a carry, take to the next stage, right? Is that the only way of doing addition? How would children add? Maybe they'll say keep 34 in the mind and then keep counting.
Keep repeating it.
Yeah, so that possible. There is no unique way of doing it, right? The result is still correct, same, always same. But how do you add could vary, right? In an implementation, you may use adder, hardware adder, or you may use an algorithm to add. It could be different. And in Python, how many of you know Python here? So it's sort of becoming lingua franca now. Every operation of that kind, even that is a function of a class. Integer is a class, right? So we do distinguish these two. So when we start discussing a data structure, we should say what is the interface, what all it can do. We don't have to worry about how. And the client can write a program based on it. And then you can write the implementation. You can chain the implementation. Some other client can use that. So there should be total independence between the client and the server code, right? That's what we are going to demonstrate now. So I don't bring anything, I do everything in front of you. I'll make a directory in that I try my first implementation. I'll make a simple list. Then maybe you can add something more to it later in the afternoon. And if there are any queries, keep asking, okay? Is C still studied in your schools or colleges or university, or it's not banned as it? Okay, it's all ML time, right? So Python and Python and only Python now. I love Python, I love C++. But yeah, every language has its own place. Okay, so I'll have 3 files here. So okay. So this shall be the interface, okay? So this should capture what is a list, not how, okay? So we'll make a list an opaque structure. The user is not supposed to know anything within it. If you're using an object-oriented language, you can hide them by making them private, okay? So whenever we start a header file, in C programming, we start with help of a macro, okay? And the name following it depends upon the convention in the company. So this is something we always do. How many of you use this structure? And would you know what that would mean? And why we use it? No? Should I discuss that sometime? Yeah, we'll do it later. Okay, just remind me, because it's not a part of the flow. It's somewhat about syntactic features of C programming. The basic idea is that if by chance a header file is included more than once, do not expand it. Only expand once. Let's say, for example, you include std.h. That may also include std.h. You may not know. You can't go and search in a tree structure, right? So to avoid multiple inclusion, this is one possible structure in C programming. Okay? So let's not worry at this point. Maybe I'll make an example. Just remind me later. Okay. So within this, I'll create a structure called this. I don't know what it goes into it. And then I use a type def and I name it with a particular convention. It's the normal Unix convention. We have a type ending with _t. Have you used type def? In C programming, have you used type def? You have. Why do we use type def? Yeah? Okay, let's give a chance here. Why do you want to do that?
So that it's easier for me to use it in my program according to my analogy, whatever I want to use.
Are you saying it's a shortcut instead of two names, I'm using a single name? Or something more than that?
We can give allies more than
Yeah, is that what, just that? There is something much more intricate about this particular feature. Okay? That name that I use now becomes an interface. The client will use something called list _t. He doesn't have to know which structure it is. I will adjust that outside, right? In case any of you used Unix system calls, if you play with something called signals, there is a data structure called /set _t. And that /set _t is the name on which I write my programs. I've seen in different Unix flavors, they are different. In one case, it's an array. In one case, it's just a 64-bit integer. I don't have to worry about it because that name is an interface for me. Stepanov is the man who designed a library of data structures and algorithms in C++ called STL, Standard Template Library. He also retired early. He is now into theology. And he says when he dies, on his cemetery, the epitaph should be while first not equal to last. Okay, so it's something. Maybe I'll also try to mention that later in the day, if I get a chance. And I keep saying that when I burn, my body will be burnt off. There will be no cemetery for me. If somebody were to build one, on the top of it, they should write interface and implementation, right? So the most important thing is the concept of interface here. Okay, now we have a name for it. We have a name called list _t. Okay, now what all can we do with a list? List is there, so we don't know what it is, it's there. So I want to know, write all functions that we have, only the interface of it, the declaration of the function using which I play with the list. So what can I say? Display all the elements could be one, okay? The first thing I would like to do is to put something in it. I have to initialize the structure. In case you know object-oriented programming, we have something called the constructor. A constructor does initialization. Initialization is also a resource acquisition. It's called RAII in C++, right? So we'll have to initialize the list, okay? So the first thing we'll try to say is this. I have a function, initialize the list, and what I give to this is a pointer to list. Okay? We also require deinitialization. I'm not writing it now, I leave it to you as an exercise later in the day. Okay? We'll try to start with a few minimal operations on it. As our friend asked, we'll have this, a function to display the elements in the list. Okay, what else do you think I should do? What do you display? I have to put something there before that, right? So what do you think I require? Add, what do we call it? We call it insert. And we'll try to make an ordered list, okay? So insert into the list. What all do I require to insert into the list? The list and element to be added, okay. I'll call it key, right? So this completes my interface. It's incomplete. As of now, my list is this. Your list could be different. Maybe you may want to have delete element based on the key, maybe delete based on position, or you may want to have searching in it. There are a number of things. right? I only develop a few things, other things you can try for yourself, right, in the afternoon. Based on this, can I write a client program which creates a list, put some elements into the list, and displays it? Can we do that? I have no idea how the implementation is going to be made. Shall we try that? So what do you do now? I write the client program for it. How do we start? Okay. So in the client program, it's a C program. In all C programs, we'll include some IO operations. So we require this header file. And this is my program. I'm playing with the list, so I also require the header file of the list. And in this, what do? I create a list. Then what do you think I should do? I must initialize the list. And to this I pass a pointer to the list. And to add elements into the list, I'll make my life a bit easier. I don't want to keep on keying in. So I will have some elements here, something like this. And now I'll have a loop. Within the loop, I'll call insert. Insert into the list the element to be inserted. Then what's the next thing I should do? Display the list. Okay. Time being, I'm not calling deinitialize, like the destructor in case you know object-oriented programming languages. Java missed it out. I do this. Is that difficult? Can I compile this? Why not? That's what I want to do. So I'll go here, I say GCC -c client.c. It's compiled. And if I look at the directory, there will be an object file, .o. If I use a command called nm, I don't know what nm stands for. Unix is so cryptic many times. So if I look at this, it should show me that there are functions like init list, insert and display, which are not defined. Main is defined, T, and the rest of them are not defined. Something with underscore is all part of the library, I don't worry about. Okay. So what I suggest is that when you teach, do not use slides. Do not use IDE. Do everything in front of them and show. That's believing, right? And ask them, okay, change one, I will change it and we'll do something else again, no problem. Maybe sometime it could fail, it's okay, right? As a teacher, the first thing I learned is to say, I don't know, right? Any queries at this point? So now we'll have to put the implementation. So we'll start with a linked list implementation. Then I'll discuss with you array list. As usual, right? Teachers solve the simpler ones in the class and leave the tougher ones for others to do. So I'll leave the other one to you to try in the afternoon. Okay, that'll be a lot of fun. That's the reason I require the board. Okay, so shall we start writing it? Okay, I'll tell you how my logic is going to be. Then you can help me out in this. Can you see? Yeah. You can, right? Okay. So my list is this structure. This is my list. I'm making a linked list. So within this, I will have a pointer to a node. And my node structure, as usual, will have two fields, the key field and the link field, or whatever, or next, or whatever you call it. And this is traditionally called the head, and it will point to this. And this is the way I want to prepare. This is my idea. Okay? So I'll start with this structure, and then I'll start with this structure also. I will have to change the header file for this Unfortunately, directly it's not possible to do. Indirectly, we can do by using a technique called PIMPLE. It may not be possible to discuss. Offline, we can discuss if you want. PIMPLE stands for Pointer to Implementation. In that case, we can avoid recompiling the client code even when the structure changes. But with the limitation that we have, we'll have to recompile once the header file is changed. After that, I won't touch it again. Okay? So I'll have to change the header file to include these two structures. I won't define the function in the header file. So let's start with these two now and see how to proceed. So we do require these two files. I will also require here standard library. Okay. This is, before that I should complete this. So what I will do now is to have a structure called node. And within this, I will have two fields, key and link. Okay. Should the user be allowed to use the link field? If he uses the link field, then if I want to change my structure to something else, I can't do it. His programs will fail. As I said earlier, the biggest challenge in software is maintenance and not development. So whenever, okay, there's another word we use, encapsulation. Have you come across the word encapsulation? What would that mean? Encapsulation. You put things together, capsule, encapsulate. You might be able to hide data or expose. Why do you want to hide data?
User cannot change it accidentally.
That is not the reason at all. Very unfortunately, a couple of concepts are totally wrongly understood. Encapsulation is not security. Data is always anyway stored the same way, right? Maybe you can go in and check the data. Yeah, some soft ciphers, you can look into it and do it. So the basic idea is that I should be able to change that data item, remove that, or put it in different way. It should not affect the client. Encapsulation is not a security issue. If you want security, use encryption. It's basically a maintenance issue. Very unfortunately, I don't know whether the books say that. That's the way it's taught everywhere, that encapsulation is security. It is not, it's maintenance, right? For example, if I remove the field called link, and if he's using it, his programs won't even compile anymore. We want to have the separation of the implementation from the user program. The only place where they depend on each other is the interface. There is no direct dependency between them, right? So encapsulation is a maintenance issue and not security. In case we are doing programming in a language like C++ or Java, I could make them private. If the client uses it, it will be a compile time error. But I can't do that in C, right? So we use conventions, right? The normal convention in C program is that if the name has an underscore, either in the beginning or the end, the client is not supposed to use. The implementer is saying, I may change it anytime. So you'll be in trouble if you use it. That is the indication. So I want these to be implementation fields, so we'll use underscore at the end. We'll try to be consistent in that particular convention. There is no compiler support in C for it, right? So what do? We'll now have this. Is that okay? And to make my life easier, and also have a single interface, I will use this type def. Okay. Now I'm ready to define my list. My list will have the head. Oh no, what did I do? And again, already I have this. So this is all it is. I'm not going to change the interface at all, so I can, it's a mistake there. Oh, there was a yes somewhere, I think it went off. Yeah. Compile time errors are okay, right? Unless it is C++ STL. There sometimes you get to, now of course from 2020 it has changed a bit, 2023 it will change. Yeah, okay. Now that's done. Now we start the implementation file. So you know what I'm using, right? So if you have to tell me how to write these 4 functions. I may not even write the second one at this point. Okay. So what do you think I should do in this function? What shall I do? I have a structure called list, and that has a field called head within it. What do you think I should do when the list is empty?
Null.
Make it null? That's it? All right. And the beauty of this is that when I'm thinking about insertion list, I don't think anything else at all. This, I don't know. So we'll just say to do and leave it here. Assume that it will be called at the end. So far it's okay, but we should write somewhere. How do you display the list? I have in the list a field called head, and that is supposed to point to the first element of the list, if any, otherwise it will be null. What do I do?
Checking the list as a divide.
Otherwise, we'll assume that it will do nothing, right? So what I may want to do is to call a helper function from here to display. Okay. To this, I may pass the head of the list. Okay, so what I get here is a pointer to node. I'll just call it temp as usual, right? So now temp is the pointer to the first element in the list. What do I do? Walk through it. Want to make it recursive or iterative? You mentioned recursion once, so.
Iteration is the easiest way.
Which one?
Iteration.
Okay, we'll do that way itself, no issues. Yeah, if you're using a functional language, then you may have to use recursion because some languages like Lisp have no looping at all. They only support condition check and recursion. Okay. They won't even support assignment. So what do you think you should?
It is mentioned like you have to use only when the problem is complex, right? Otherwise, better way is always iterative.
Yeah, iteration is normally faster, yes. But there are cases where expressing in recursion is much easier.
Yeah.
Think of algorithm like quicksort or merge sort. Writing it non-recursively is not at all easy, right? We tried some experiment, conversion of any recursion to iteration. We're able to do it. We looked at 4 different types of recursion, but we couldn't beat the clock. It became slower than the earlier recursive program. So we left that experiment at that point. So this is easy, right? Would that be okay? Any queries about this? Shall we proceed? Now we look at insertion. Insertion is a bit more complicated, isn't it? What are the different cases we get while doing insertion? In the beginning,
At the end.
end, middle, one more. And we are not doing it. It's ordered list, so you have no choice. One more. Middle, beginning and end. One more.
Given position.
Empty list. Given position, I can't do if it is ordered. It could break that predicate, right? So you can't do it. Empty list, right? Okay. So we'll consider all this and try to do it. I will keep doing it quickly, but if you feel I should discuss the way it happens, we'll do it on the board, right? Otherwise, I'll just do it quickly. I'll keep, of course, saying what I'm doing, okay? So, first thing we'll check is the case of empty list. How do we know list is empty? What will tell us list is empty? Is that okay? Otherwise, do something else. You might also observe the way I key in. The minute I open a block, I close the block. I will never miss the blocks that way. But before that, we can do one more thing. We have to anyway make a new node, right? So we'll make a new node here. And again, as usual, call it temp. And I'll call a function to make a node. And to this, I'll pass the key. So one more thing here. The last function we just wrote, where is it here? Do you think I can use the word static here? Would that make a difference? What could the word static mean here? Huh?
Changes to the last update.
No, no, no. Static is a word I hate in computer science. Basically because the word has at least 5 different meanings depending on the context. Whenever a new concept comes into your language, we have to support using a keyword. If you make a new keyword, what happens? If that has been used in programs earlier, all those programs will fail now. To avoid that, what is normally done in language design is to use an existing keyword and give another meaning for it. Right? If you just talk about C, the word static in C has different meaning depending upon whether it's a variable or a function. If it's a variable, again, there are 2 possibilities, external static and internal static. If it is external static, the variable is available only in that file. It has what is called the internal linkage. Okay? And if it's internal static, the variables allocated in the beginning, it holds the value between the calls. That's what I think you're referring to. But static for a function is different. We have no nesting of functions in C++ and C. Therefore, I can't have internal static there. We only have external static. This indicates something called internal linkage. This function cannot be called across the files. Right? You compile the programs, you link them, and then load them and run them and so on. During the linking phase, this name is not given to the linker. The compiler will absorb the name, so there's no way the client can call the function. Right? If I want to write a function which is sort of hidden in my file, I can make it static. Right? So the right word for it is internal linkage. Okay. So same thing here too. This function which I'm going to write now can be static. Can you tell me the signature of the function based upon the call? Make node. What should the function return? Pointer to node, right? Thank you, that's good. And it takes an integer. And it uses allocation here. Time permitting, we'll discuss a bit more of the function malloc. and I populate the function. I do not have to really worry about the pointer field. I'm going to take care of it anyway. And some people feel it is safer to do this. I don't feel, but I'm still doing it. Okay, so I get the node. Now we go into this here. What do you think I should do here? I'm adding a new node. So the head should change. And nothing after that node, so I make it null again. I don't have to do, already I had done it. Otherwise, what do you think I should do? If I want to insert somewhere in the middle, I must traverse. And this traversal is one way, right? I can't come back. So either I have a look ahead, see the next node, or keep 2 pointers, one tagging behind the present. I will use a second technique. You can try the first technique if you want. So what I will do here is that I will have a pointer called previous, which I will ground, and a pointer called present, which is the head of the list. And then I will traverse while I have not reached the end of the list. And assuming that I'm trying to create in ascending order, so I'll check the key less than present arrow key. I move to the next node, and I make previous tag behind the present and change present to the next node. So anything you want to ask about this? Is that okay? Comfortable? Shall we proceed? If there's any mistake, let me know. Then what do you think I should do now? Once I come out, I got a position to insert. And at this point, if previous is still null, what could that mean? I think I made a mistake here. Very dangerous mistake. Okay. So what would that mean if previous is null? Insertion in the beginning, right? So you insert in the beginning, head will have to change. If it is not the beginning, it could be the middle or the end. In this case, the head won't change. So what will change here is the link field in the previous node. Right? Even at the end, the same code works. Anything you want to ask about it? I don't know. There could be some mistakes. Syntax, logic, I have no idea. Let me see. So I'll try to compile it. I like this.
So that if statements will be after while.
Link is not given as a pointer.
Link is not given as a pointer.
The node was defined.
Thank you. That means I recompile the client. Okay. So 43 and 46. This code will have to come within. Okay, so now we have compiled. if I use the nm command and have a look, I'll be able to find that these functions have been defined. This is static function, right? And these are all still undefined. They come from the library at runtime. They call it dynamic library concept. So that's how they'll come in, okay? So now I had to put them together. For that, I had to do linking. For that, also use the same command GCC. It acts like a facade. So in this, I will now give these two. And I can give a output file. Then I should be able to run this. If everything is fine, it should come out. It came the other way. That means my logic here hasn't been that correct. This, okay. So maybe we'll change it here. We'll try to get in ascending order. It may be easier to think that way. It shouldn't really matter much. So I was giving more importance to the structure. I didn't think of this logic correctly. So I only changed the implementation file. I'll only recompile this. Bracket is missing here. Okay, I link them now and run them. Okay. Anything you want to say? How many of you will try this out in your classes? Nobody? Nobody, why? Is there some challenge in it? I also made compilation mistakes. It's okay. Logically also I was not correct in ascending order. But don't you think if you try this way, the students get more confidence to try on their own? Right? I think you should do it. You should throw away PowerPoint presentations. Do in front of them. Or if you feel that you can't do it totally, maybe get some structure and template and fill it up. But you should compile and show it in front of them. And please make it a point to use multiple files. Clearly distinguish between the interface and implementation. Anything you want to ask at this point? One question I have to take, I'll come back and take it. Time permitting, I'll again discuss malloc later. Okay, I think we have around half an hour time before we take the first break. Anything you want to tell me at this point? Okay, now we'll try a new experiment.
So this particular style is best suited for when the lab and this is together, right? I mean,
In the class,
otherwise what happens is, I think many times you're concerned that the amount of time that it takes to...
it won't take much time. It won't take much time at all. This has been done. I tried a number of times in PES. And many teachers have changed based on that. At least I know some 10 teachers have changed based on my way of doing. No matter what, it could be pretty complicated algorithm like AVL trees. I've done here. Okay. I think it's a misconception that it takes more time, right? Okay, now, are you okay with this? Are you comfortable? Now let's make a small change. I do not want the client to know anything about what I'm doing. His program should still work. Can I see something like this? My empty list will have one node. Even my empty list will have one node. That's my change. How could that help? What could be the idea? So what I'm trying to say is that this empty list which I create, I will have one node here. That node will always remain. Okay? So what we'll try to do now is to take all these files to another directory. I won't change the client, right? I'll have to recompile the client because I'm going to modify the header file. But I won't change anything in that file. You can check the timestamp. I will be having the same thing. But I will modify my implementation, right? Let's see if it still works. Are you okay with me? Fine. So how do we do that?
So why it is negative?
I will tell you, it's pretty interesting when you write the function. And many of these techniques are very commonly used. Okay, these 3 files I will share. So if I want my empty list to have one node, should I modify anything here?
Unit list.
Huh?
Unit list.
Yeah, here nothing, right? The header file, nothing is changed. That means I don't even have to recompile the client. Maybe I can keep it above itself. So I could have even taken the old file itself, but I deleted that. Oh no. Okay, so I will not touch this anymore. It's an old file. I haven't changed the time also. It's showing some time, so 105, whatever. Okay. So now I'll change the implementation. What do you think I should do here? So I had to make a node. In this particular example, it so happens that it doesn't matter what value we put there. In some examples, the value could matter. So I'll say make node. I can put anything here, some value. As I said, in this example, okay. And what I'm doing here is a concept called the header node concept. Okay, done. Now, how do you take care of display? Would this be correct? Does this head point to the first actual node in the list? Are you with me? In the beginning of the list, we have one extra node. When I make an empty list, I put an extra node. It has a key which we don't care. So what do you think I should do in display? If I call this way to display that value also, I don't want that. What do you think I should do? Jump over that. So what do you think you should do? You'll say now? Simple change, right? Okay. Now please help me modify this. Will we ever have this particular case? Please think. Will the list be actually empty anytime at all? Would there be any case where we had to change this field in the list? No, right? So can I drop that condition? We said there are 4 conditions to consider in case of a list. Empty list, add in the beginning, add in the middle, add at the end. Do we require the empty case? No. I'll drop it off. That means if is gone. So my logic becomes simpler. So no empty list case. No. Oi. How do I get it back? Shift it. Shift delete? No. No, I want it to be tapped back. Okay, doesn't matter. Because I don't like if things are not properly indented. So we have removed one case. Okay. So we traverse like this. That is required anyway, right? How about the initial value of previous? It should be just behind the first node in the list, first node in the actual list, not the implementation. Should that be null? Okay, what about this here? Is that correct? Is that the present node? Present should be the first node in the list. So what do you think I should do? We should skip over the first node in the implementation, right? And what about this here? Okay. Will this be null? Will this condition ever happen? So can I even knock off all this? And how does this code look like? We'll run it and then come back and discuss it. So let me see where I am. I'm in list 2 and I have the client program compiled. So now, let me have your comments. This is a very common technique called time-space trade-off. We try to gain in time at the cost of space. We use one extra node. This could be any length, but look at the logic. It has become so simple now. And definitely maintaining this code will be much easier than the one with so many cases to be considered. Testing becomes easy here again, isn't it? So this is the concept of header node. One, but more importantly, what I have shown you now is that when I change the implementation, the client hasn't changed. That is the main concept that I'm trying to drive at today, that the client code depends on the interface, which in case of C programming and C++ programming is the interface. In case you know Java, there is a very interesting concept called interface itself in Java. Right, according to me, that's the only thing that's good in Java. Then the implementation depends upon the interface. The client code does not depend on the implementation. The implementation does not depend upon the client code. Are you comfortable with this? We have tried these experiments in some companies, many companies actually. So we say, okay, two of you should work together. So one of them will provide the support, other one will use it. And we tell them, okay, talk for next half an hour, come with the header file. And then you separate. After that, you can't talk to each other. More often than not, within 15 minutes, they'll come back and say, no, sir, we have to talk to each other because they want to miss out something. So the most important thing is to design the interface. Maybe you want to try it out later in the afternoon. We can hook up some example where you work in pairs and see how it works. So anything you want to ask about it? So we use the header file to make the insertion more efficient, more clean. Can we similarly have a node at the end? additional node at the end. This will be one of your exercises for the day. So you may want, I'm not going to try it. Can I have a node at the end here? So my list structure will have 2 pointers. First pointer could point to the first node in the list or the header node, depending upon whether header node also is part of this implementation. There is a tailor node which will point to the last node in the list. What could be the use of it? It always remains at the end, tailor node. What could this be? Do you think it will help in insertion at the end? Just think. Without copying the data, do you think it will help in insertion at the end? It can't. The reason is when you insert at the end, this pointer has to change to that new node, and then that has to point to this. And you can't move back. Even though you have pointed to this, you can't move back. Unless you copy data, you can't do it. No, it should be the last node. That is the tail. It can't be in the middle, right? So where do you think this could be useful? Header node is for insertion. And what is tailor node for?
Show the end of the list.
Show what?
Show the end of the list.
Yeah, so that you'll have to use anyway in your display routine. You will have to say, when I come there, stop. Instead of looking for null, you should check whether a tail is reached. But it doesn't make much of a difference anyway. We are already adding one extra node. There should be some use for it. Okay.
Use it as a queue.
No, they can't be used as a queue. If you want to use it as a queue, I should be able to remove the last node. I can't do it. I can't add at the end, I can't remove at the end in a constant time. It can't become a queue. The requirement of a queue is add in the beginning, remove at the end. And both should be only a few operations. It should not require a loop. Here I can't do without it. That's a very interesting question. Okay, how do you search in a list? You're asked to search in a list. How do you search in a list? One more question which I just mentioned, but we'll take it after the break. What do you return in a search? What should search return? Okay, I'll take it later. Maybe you can think over coffee or tea and then come back. How do you write a search function in a list? Given a key, I have to find something. Yeah?
Start from the first.
Okay, start from the first actual node. Okay, you have a loop there, right? And what do you say in the loop conceptually? Yeah, if the key is not found yet, that's all? End is not reached. That means, and then move to the next node, very similar to the way we have been doing. That means you require 2 conditions in the loop. Are you okay with it? Each time you should say whether the element is found or we have not reached the end of the list. To be precise, it should be in the reverse order because C uses what is called short circuit evaluation. You know what it is? Short circuit evaluation. Okay, they will take that also during this short break. Okay. I could have even mentioned that earlier. Fine. Can we do something like this? When we have a tailor node implementation in a search function, we are given the key to search, isn't it? Can we copy the key to the tailor node? I said, right, when we add dummy nodes, we may or may not use those fields. In this case, I want to use it. What do you think happens if I copy the key to the tailor node? I copy the key that's being searched here. Is the element always found? Either in the part of the list or in the tailor node. do you have to compare whether we have reached the end of the list? In the while conditions, I said there are two conditions, right? Do we require the condition to check whether the end of the list is reached? Anyway, we'll hit the key there. If you have a long list, now using this Taylor node, instead of two conditions being compared each time, I will do only one comparison, right? One extra node, knock off one comparison in a loop. Header node is for insertion, and the Taylor node is for searching. So I leave it to you as an exercise. Take this, modify, first provide a search function in others also, and then modify to have a search function where you have a Taylor node, copy the key there, and so that your condition becomes shorter and simpler. Are you okay with this?
Value is found twice, then
Huh?
value is found twice, that means the value is in the
Earlier it is found. Whenever it is found, you come out.
But if the
Value
value is,
found
if the
twice.
key is not there, two scenarios. One, if the key is not there in the list, and we definitely hit the Taylor node.
Yes, yes.
So how do you confirm that?
Once you come out of that loop now, you check, are you at the tail or before? One if condition is required after the loop. In the loop, you knock off one condition. Outside the loop, you introduce one more condition.
The value is found once, that means the value is not present.
Value should be at the tail. Anywhere else, it's actually found.
Yeah, and then it will show that it is found twice.
No, the minute you find once, you come out. Once you find either, okay. These are commonly used techniques. Almost in all operating systems, this header node concept is very commonly used. Taylor, not much, but header is used, right? See, these are two techniques I'm talking about, but my more interesting thing is to talk about the interface and implementation, that the client doesn't have to know whether the list is a simple list, has a header, has a tail node, or both. He doesn't have to know. That is the most important aspect. Okay. So we have, I think, some 8 minutes of filler. So now I'm not talking about any of these lists now. Once we come back, I'll introduce another concept called the iterator. Then I will introduce an array list, which will be a bit confusing, and hope you have enough coffee or tea, enough caffeine so that you don't go to sleep. Okay, so let's look at some final points that I mentioned. Okay. Remember, we had a loop like this while previous arrow key less than temp arrow key. Can we write something like this? If we have two conditions, C1 and C2, how would this work? Do you study K maps by any chance? Karno maps? You do? Okay. There's only one computer science. All subjects are related, right? So what should happen here if you follow the normal two tables? Find the value of C1, which should be true or false. Find the value of C2, true or false. If both are true, result is true, otherwise false. Is that the way most of the languages work? Have you come across something called don't cares in K-maps? Don't cares? If C1 is false, assume that you evaluate left to right, is it ever possible for the whole expression to be true? C2 becomes a don't care, right? If C1 is true, then we can't decide, we have to go to C2 also. What most of the languages after C, not before that, do is this. They evaluate a logical expression left to right. That's guaranteed. And as soon as the truth or the falsehood of the expression is known, the evaluation stops. And that is called short circuit evaluation. So this expression is wrong. Other way is correct, right? In this case, if I write other way, if present is null, this expression is never evaluated. That would be a crash, right? If present is null, right? Dereferencing a null pointer is a guaranteed crash. Other way I should write. So this is what I want to tell again. The order matters. So if this is true, only then we should do this. That is the concept of short circuit evaluation. It was not there in Fortran, COBOL, Pascal. It came in C, and from that point, every language is using this. Okay. By the way, which books do you follow for C in case you teach C at all? This is the only book you should follow. Okay. Tough book. Cannot understand in first reading, right? And one other book which you may want to look at is the C puzzle book. Okay. Both are amazing. C puzzle book has number of small programs. We have to find the output. The programs are very tricky. The output is given as well as explained, right? Okay. I think we'll stop at this, just 2 minutes now. So another question, hash if define is not yet taken. I'll come back and take it sometime. So any feedback for me at this point? I'm with you for 3 sessions today and 4 more sessions on Wednesday. So how are we going so far? Any feedback? Not comfortable? Something of value? Time not wasted? Okay, so I give my email ID also. I'll also share with you. You can always contact me even after. Okay, we'll take a break now.